Okay, the factor remainder theorem. Let's kind of recap a synthetic division question. So x cubed minus 3x squared plus 5 is divided by x minus 2. Okay, so when we set this up, synthetic division, we use the 0, so positive 2, and then we take the coefficients, and remember that decreasing order, so cubed, squared, and there's no x term, so we will have to replace that with put a placeholder of 0 in. So 1x cubed minus 3x squared, 0x, and 5. Okay, so we have that set up. We bring this down. That's a 1, so this becomes a 2. Add, so that's negative 1, and then that's negative 2. We add negative 2, so that's negative 4. We add and we get 1. Okay, so in this division question, we have that it would equal x squared minus x minus 2 with a remainder of 1 over x minus 2. Okay, so what if I just want to know the remainder, or if I want to know if it's divisible? So obviously this is not a factor because it had a remainder of 1. Okay, so it's not a factor. Okay, so if this number comes out as 0, then it is a factor, or if there's no remainder. So what we can do now is, the shortcut for just the remainder is to plug 2 in to f of x. Okay, so I'm going to plug, so the 0, 2 into this equation. So 2 cubed minus 3 times 2 squared plus 5, I get 8 minus, that's 3 times 4, so 12, plus 5, and that comes out to 1. So you can see that we got the same remainder when we did synthetic division as when we plugged that 0 in. So therefore, the remainder is 1, and it is not factorable. Okay, I'll give you another one. Find the remainder. Okay, so we're going to plug 2 into this equation. So evaluate the function at 2. So 2 cubed minus 3 times 2 squared plus 4 equals 8 minus 12 plus 4 equals 0. Therefore, x minus 2 is a factor of that polynomial. Okay, so knowing that, since it is a factor, we can go further. Okay, so I'm going to use synthetic division, and I'm going to divide. So 2, and take the coefficients 1, negative 3, don't forget to placeholder 0, and 4. So we go down 1, this is multiplies to 2, add this line, negative 1. Multiply, negative 2, add this line. Multiply those two, negative 4, add this line, 0. Okay, so again, there's that conclusion that the remainder is 0. So now, when we go further, and we want to display all the factors, x cubed minus 3x squared plus 4 equals...
Laura Thiessen, when you have a moment, please call my extension, which is 2005. Yeah, call me. Bye.
So there is one factor, because we knew it was factorable, because the remainder was 0. And what is left is the coefficients 1x squared, negative x, and minus 2. Okay, and now we can continue to factor, because this trinomial will now factor x minus 2, x plus 1. So now you've fully factored this polynomial. Okay, that is the remainder theorem.